Hey everybody, welcome back to Chapter 9. We're just about halfway finished with Chapter 9, and today we're going to talk about subtracting fractions with like denominators. And again, I'm going to combine two lessons into one video here. The first lesson is section 9-4, which deals with models or pictures to help you subtract. Here I have my two pictures. Lesson 9-5 deals with just the regular algorithm of subtracting fractions. So let me do an example or two here from 9-4, and then we'll get set up and do a few examples from 9-5. 9-4, we're going to use the models here to subtract. Now in my opinion, I find this to be a little more challenging than addition, because for addition, you just color in what you start with and then color in also what you add on to it. However, with subtraction, like we know, we start with a total number and we're going to be taking away from that total number. So, one major difference between the addition models and the subtraction models is this. My models here are broken into eighths. However, my problem is 6/8 minus 3/8. So I need to just use 6/8 rather than the full-on amount of 8/8. So I'm just going to draw 6/8. Now notice, compared to my one whole strip, 6/8 stops right about here. What I did to represent the other 2/8 so that I know I drew my figure properly, 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, and then I put a dash and a dash where 7/8 and 8/8 would be. So I'm only going to talk about 6/8. Of those 6/8, I'm going to subtract 3 of them. So what we did in class, we could go 1, 2/8, 3/8. How many eighths are left? If you started with 6/8, you took away 3 of them, 1, 2, the correct answer is 3/8. It's a lot of work for a simple problem, but it's something that we are going to need to focus on as we move forward. My second example here, I have my one whole bar, and I've broken this into tenths. My problem here says 8/10 minus 5/10. So what I've done again, I've numbered 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, put a dash for 9/10 and a dash for 10/10. The reason I did that is because I only want to work with 8/10. I don't want to work with the full allotment of 10/10. So I started with 8/10. I'm going to take away or subtract 5/10. 1/10, 2/10, 3/10, 4/10, 5/10. How many tenths am I left with? Well, 1, 2, 3. The difference is 3/10. Again, the trickiest part about setting up your models is resisting the urge to make your eighths go all the way, because you'll have 2 extra spots, or the tenths, all the way. When you get to the number you're going to be starting at, for example, 8/10, 1, 2, 3, 4, 5, 6, 7, 8, remember, however many remaining pieces, I recommend putting a dash until you get to the one whole. Alright, so that's a very basic summary of 9-4. 9-5, let's take a look at it here. 9-5 is simply subtracting across the numerators and keeping your denominators the same. For example, 7/12 minus 3/12. Just like adding, we're going to do our operation to the numerator and always keep our denominator the same since they're alike. 7 minus 3, 4. Keep my denominator of 12 the same. The difference between 7/12 and 3/12 is 4/12. 13 fifths minus 4 fifths. Now, I started here with two improper fractions, 13 fifths, or excuse me, one improper fraction, and I'm subtracting a regular fraction, a proper fraction. I'm going to do the same exact thing. 13 minus 4 will get me 9, and my denominator stays in fifths. Now, as a quick review, and as a jump start to what we're going to be doing later on in Chapter 9, how can I change 9 fifths into a mixed number? I don't want to leave it as an improper fraction. I don't want my numerator larger than my denominator. So one strategy we've talked about is breaking a picture into fifths and coloring in 9 of them. 1, 2, 3, 4, 5. I'm not finished though, because I have to color in 9. So as we talked about in class, draw yourself a second figure, break it into fifths, and continue your coloring. So I've colored in 5, 6, 7, 8, 9. How many whole rectangles have I colored in? Well, I've colored in this entire one, but I've not colored in this whole entire one. So I have one whole rectangle colored in, and how much of this second one? The correct answer would be 4 fifths. So 9 fifths, written as a mixed number, is 1 whole and 4 fifths. 1 and 4 fifths. I hope this helps you a little bit with sections 9-4 and 9-5. You've done a very great job today in class, and I'm looking forward to finishing up the rest of Chapter 9. Thanks for watching.